Okay, let me fix this there. I think we go. There we go. Okay, so we just ended off at this slide. Let's talk about the opposite. So we were talking about peripheral dilators. Let's talk about local constrictors, things like prostaglandins, thromboxanes. These are just local hormones, kind of little cell-to-cell communicators. These are released specifically by damaged tissue. They're going to constrict the precapillary sphincters, shut off the blood flow to a particular area to allow for blood conservation. So neural mechanisms would be mostly controlled through a medulla oblongata, the cardioacceleratory, cardioinhibitory centers. With vasoconstriction, we're talking about androgenic nerves responding to norepinephrine, stimulating the smooth muscle within those arterial walls, constricting, right, contracting them, getting them to be smaller. Vasodilation, it's the cholinergic receptor, so the ACH getting relaxing. It could also be nitric oxide, again, allowing for that dilation, allowing for the smooth muscle to relax and the nitric oxide to come in. So that creates what's called a vasomotor tone. It's this balance between the constrictors, allowing for your vessels to maintain a certain kind of rigidity to them. Again, the cardiovascular centers are going to monitor our arterial blood. There's baroreceptors and chemoreceptors. Baroreceptors respond to pressure. Chemoreceptors respond to like pH and dissolved gases, O2 and CO2, which are related to pH. So with our baroreceptors, they're within the carotid sinuses, maintaining blood flow to the brain, aortic sinuses, maintaining and monitoring the systemic circuit, and then also within the right atrium to look at venous blood return back to the heart. And then this is the feedback loop. Again, maybe pause it here, see if you can understand how all of these things are going to affect homeostasis and the cause and effect relationship that exists. Ultimately, when blood pressure rises, the cardiovascular centers are going to decrease cardiac output, try to slow down, dilate everything, make everything nice and big so pressure can decrease. And then the opposite, when pressure falls, those cardiovascular centers are going to start increasing cardiac output, putting more blood into the vessels, allowing the vessels to get smaller so that pressure builds. Chemoreceptors monitoring CSF, they're located in the medulla oblongata as well. They're going to help monitor the CSF, control our respiratory function. So within the medulla oblongata, you have your cardioacceleratory and inhibitory, but you also have your respiratory centers. So if your blood pH is off, it could be because you have too much carbon dioxide. Or if you have too much carbon dioxide, it probably means you're not breathing enough. So not breathing fast enough. So you have to increase your respiration rate to get rid of that extra carbon dioxide, etc. It's also going to help control the blood flow to the brain because if your blood pH is too low, well, then those little shunts are going to start shutting blood flow down to the brain because you don't want to damage your brain with having acidic environment. So again, this one would be a good one to kind of pause and see if you can understand the cause and effect relationship going on with homeostasis and chemoreceptors. Chemoreceptors are always going to respond to pH, O2, and CO2. Again, CO2 and pH are pretty much the same thing. We'll see that later, but it's going to coordinate cardiovascular and respiratory centers. The CNS and the cardiovascular centers are going to change how the way your cardiac system pumps the blood as well as the vasoconstriction. So constricting or dilating and increasing or decreasing cardiac output. There's also hormones. So hormones have a much longer effect in our system than, say, a nervous impulse. Epinephrine and norepinephrine are going to be our constrictors or dilators. You have ADH, antidiuretic hormone. This is coming from the posterior pituitary. This is going to elevate blood pressure, increase blood pressure by reducing urine output. In other words, increasing reabsorption at the kidneys, allowing for our body to retain fluid and maintain blood volume. So the ADH is going to be released in response to a low blood volume or a high osmotic concentration in our blood, as well as angiotensin 2 circulating around in the blood. What is angiotensin 2? Angiotensin 2 is going to be released in a response to low blood pressure within the kidneys. It's going to stimulate aldosterone. Aldosterone stimulates ADH. production. It's also going to stimulate your thirst and cardiac output and vasoconstriction so that pressure can increase in that smaller diameter. EPO, or erythropoietin, is released by the kidneys. It's going to stimulate red blood cell production. And the natriutetic peptides, I think your textbook calls them the natriuretic factors. It's the same thing, ANF, BNF, or ANP and BNP. Same thing, they're within the heart, though. So these guys are going to be released under times of high blood pressure to lower the blood pressure. These are the only two that lower blood pressure. Everything else is all about raising blood pressure, which seems strange living in our world in 2015. Most of us think, hey, it's bad to have high blood pressure, which, yes, it is. But the reason most of us have high blood pressure isn't because of our bodies. The reason why the majority of us have high blood pressure is because of our diet and other external factors, diet and exercise, mainly smoking, drinking, etc. So if you take those factors out of it and just think about our body's, natural surviving instincts, it's important for our body to maintain blood volume and blood pressure in a survivor type mentality. So that's why there are so many different responses to having low blood pressure to getting it back up. But there's very few natural responses to having high blood pressure. ANP and BNP are the only two, other than just slowing down your heart rate and dilating, your blood vessels. So overall, your heart, your cardiovascular system, all working together, all maintaining homeostasis, working together. In response to exercise, your book covers this just briefly. Light exercise ultimately is going to increase your venous return. It's going to increase your arterial stretching. Heavy exercise is going to bring about a sympathetic nervous response. So you're going to get a restriction of blood flow to your non-essential organs. So this is one of the reasons why, when you're running for a long period of time, you're not hungry while you're running, or you're not salivating while you're running, because you're all of your energy, all of your blood flow is going to your skeletal muscles to maintain, running. Blood supply to the brain is always unaffected. Here you can see how the blood flow changes to different organs during light exercise and strenuous exercise. So just look at rest, for example, milliliters per minute, 1,200. During light exercise, it goes up a little bit. During strenuous exercise, it goes up 3 times, or pretty much 12 times, its resting rate. But look at the brain, 750, 750, 750. Increase to the heart, yes, because the heart has to pump faster. But look at your kidneys. It slows down, right? Look at your abdominal viscera, your stomach, your intestines, slows down, right? Look at your overall cardiac output. Boom, right? Your cardiac output is almost 4 times what it was, or about 3 times what it was when you were at rest. So something to think about. Moderate exercise is going to play a role in lowering your total blood cholesterol levels, right? That's decreasing the viscosity, decreasing turbulence. Intense exercise could cause severe physiological stress, depending on how you're training and how you're doing it. Overall, your body is going to respond to how you treat it. So this is not dealing with this particular slide, but if you are starting an exercise program and you haven't been exercising for a long time, it's important to start slow and talk to a doctor or a personal trainer to make sure that you're doing it right so you don't hurt yourself. Because especially, I know, speaking for myself, the older you get, the longer it takes to recover from injuries. So just make sure you take care of yourself like that. Hemorrhaging or severe blood loss is going to have an effect on your entire cardiovascular system. Your cardiovascular system has to maintain blood pressure and restore the blood volume. So it's going to do that by having carotid and aortic reflexes, increasing the cardiac output, increasing the heart rate to make sure that more blood's getting pumped out into those vessels and causing vasoconstriction. Sympathetic nervous system is going to further constrict those arterioles, and venous constriction occurs also. We're almost done here. Oops, here's another. I skipped ahead too much. There we go. I would pause it here and check out this nice little flow chart on homeostasis. Finally, hormonal effects of long-term blood pressure, increasing the cardiac output and vasoconstriction. think we'll stop here, and I think this is it for our video.